Okay, we're going to do the second part of the troglodyte war problem. It says the troglodyte war continues, and they're actually aiming for someone on this side that they know is 103 meters below the top of the cliff. At what speed do they have to roll the bomb off so that when it gets across this separation, the 42.1 meters, that it hits that guy? So I'm going to start filling in my values again. The initial position is 0 in the x direction, 42.1 meters. Final position, we don't know the initial velocity or the final velocity sideways. Timer starts, but we don't know when it stops. So I got my x side filled in. On my y side, this ball starts at the top of the cliff. I'll call that 0. It's going down 103 meters. So I'll say it's minus 103 for its final position. Where it said they know that the offensive member is 103 meters below the top. So that's why it's below. It's negative 103. The speed starting out going down is 0, and I don't know the final speed. Timer will start at 0, and I don't know when it turns off yet. And gravity is at negative 9.8. So in this case, since I know how far it goes down, I know my delta y. I'm going to use this y side to find the amount of time in the air. So I'm going to choose an equation that has the change in position, delta y, and the time. So delta y equals initial velocity y delta t plus 1/2 gravity delta t squared. Same thing as before, my initial velocity in the y is 0, so this term goes away. So I'm going to solve for delta t. It becomes delta y, multiply both sides by 2, divide by g, and then I have to get rid of that square, so square root. And that's equal to the amount of time. Plug in 2, change in position vertical is negative 103, divided by a negative 9.8, square root. Okay, so type it in. Takes 4.5 seconds, a little over 4.5 seconds, 4.5848. So I can take that, plug it in to my time, 4.5848. And over here 2, same thing. And now we're going to try to find out what is the speed that it's rolled off the cliff at. I'm going to go after the velocity in the x direction initial. And the only equation I really have is this one, the delta x equals bix delta t. I'm going to solve that for my velocity. So divide both sides by delta t. You get the initial velocity in the x direction is change in position in the x divided by change in time. Change in position is the width of the cliff. Change in time we just found. So 42.1 divided by 4.5848. It's about 9.1825 meters per second. That's how fast it has to leave the cliff to get over to the other side where they want it.